Here we go. Today is January 13th.
Wait, is January 15th?
13th. All right. Today we're talking about the fundamental identities, and I sort of rearranged some stuff. I took some stuff out so we don't have to do it for this sort of semi-unit, and we'll push it and just do it in a much bigger way later. But I introduced the things here. So before we get started, we have a right triangle here, and I'm asking you to find sine of B. What does this mean? What does it tell you to do?
Opposite over hypotenuse.
Okay, so sine, the word sine literally tells us to look at the opposite and the hypotenuse legs of the triangle.
But it's from the B.
The B says we're looking from angle B right here. And that's really the most important part because the opposite side changes based on where you're looking from. So it is really important that we recognize that we're looking from angle B. In order to give the length of the opposite over hypotenuse, what do we need to do? Find that hypotenuse. How are you going to find Pythagorean theorem? So that would be 32 squared plus 24 squared, which is, I don't know, c squared. And then c turns out to be 1600, which when that's c squared. And so then c is 40. Okay, good. I didn't want to do all that work. Okay, so it turns out then that according to angle B, what's the opposite side? 32. And then the hypotenuse is 40. Good. And of course, we always want to reduce. So if you reduce that, what do you get? 4/5. So we can divide by 8. So 4/5 for the sine ratio. And that's fantastic. So then what does cosine of A tell you to do? So cosine tells you to look at the adjacent over hypotenuse legs, looking from angle A, which is way up here. So if this is angle A that we're looking from, what's the adjacent side? 32. Oh, hey, that's interesting. It's the same, isn't it? Huh. Did you notice that? Interesting. So the sine of angle B is the same as the cosine of angle A. Huh, curious. The reason those are the same is because they're co-functions. Sine and cosine are co-functions. And it turns out that before I talk about that, let me do some other things here. All right, I'll get back to that. There's this whole theorem thing that I don't really like to talk about. This is all I'm going to do on it. Let me ask you a question. If B is 10 degrees, how big is angle A? 80 degrees. Okay, good. All right. So if angle B is 20 degrees, what's angle A? 70 degrees. Good. Okay, good. If angle B is 30 degrees, what's angle A? 60 degrees. Okay. How do you know that? Okay, so all three angles have to add to be 180 degrees. And this one's already 90. So don't we always just have 90 degrees shared between A and B? And by definition, if A and B add up to be 90 degrees, would you say that A and B, angle A and angle B are complementary? Mm-hmm. Always, right? In any right triangle, angle A and angle B are complementary? Yeah? Okay. Okay, so it turns out that co-functions of complementary angles are equal. Co-functions of complementary angles are equal. And And so I could also say the cosine of angle B would be equal to the sine of angle A. Huh, that's really cool. And in fact, these aren't the only co-functions. What are some other co-functions? Tangent and cotangent, sure. Tangent of A would turn out to be the same as cotangent of B because they're co-functions and A and B are complementary angles. The reverse of that is also true. The tangent of B would equal the cotangent of A. What's another co-function? Sine and cosine. What's the other? Secant and cosecant. Yes. Secant of A would be the same as cosecant of B because they are co-functions. And that's literally what the co means. They are coordinating, shall we say, complementary co-functions. Secant of A is equal to cosecant of B. So I'll write it out. Secant of A is equal to cosecant B. All right, so those are literal co-functions. Co-functions of complementary angles are equal. All right, so I'm not going to talk about that anymore, but that's an interesting little tidbit there. All right, so let's do a few things here. Here we go. Example 1. Example 1, sketch a right triangle corresponding to the given trig function of acute angle theta. Then find the remaining trig functions of angle theta. So I mentioned last week that in your book, they do everything the very mathematical way. And I do everything the draw picture way. Okay, so I very much translate trigonometry into kindergarten math because we know all the parts when we have a picture to look at. You can do it without the picture, and you know we kind of will, but really I just need you to be able to visualize this stuff. And so first we have tangent of theta is equal to 2, and so tangent. I'm thinking, hey guys, can you help me out? What do we use to remember what tangent means? SOHCAHTOA, yeah. SOHCAHTOA. And every time I say that, I sing it to like, Oklahoma, where the wind. Sorry. SOHCAHTOA. Okay. All right. So when I look here at the tangent of an angle is equal to opposite over adjacent, I'm thinking to myself, hey, I need this to be a ratio of 2 numbers. How do I turn this into a fraction? 2 over 1, yeah. And so that's really helpful because now I have this is what I do now. Anytime you have a trig function like this, a trig equation, look, the shape there, what shape did I just make? A triangle. And anytime you have a trig equation, that's telling you, hey, draw a picture. So we're going to make a little sketch of acute angle theta. And this is acute angle theta in standard position, always, always. So in standard position, my initial side is here on the positive x-axis. What does acute mean? Less than 90 degrees, greater than 0. So I'm going to just draw acute angle theta here that is less than 90 degrees. So here it is. there is acute angle theta that is less than 90 degrees. Again, the most important part of trig is the angle, ladies and gentlemen, so make sure you've labeled your angle. Now, what I need to do with this information is actually turn it into a triangle, because these are trigonometric functions based on a triangle. And so to do that, I'm going to pick a point on my terminal side and drop an altitude down to the x-axis, and lo and behold, I turned my angle into a triangle. Crazy, right? So when you do this, and this is the best skill to learn right now, we're going to drop altitudes all over the place. It always comes to the x-axis, all right? Don't horizontal drop. Okay, we're literally like dropping an altitude, okay, to the x-axis. Okay. All right, and now I have this triangle. I have my angle labeled, and I can label the sides now. So what would this side be called? Hypotenuse. What is this side over here?
Opposite.
Opposite. What is this side down here? Adjacent. Good. And they gave me some information. Tangent. What does this 2 represent? The opposite and the one? Adjacent. Yeah, so I can give it some numbers here. So the opposite side is 2, and the adjacent is 1. So the very first thing we did was draw the angle with the given information. Now, if we want to find all the rest of the trig functions, what do we need to do to complete this triangle? Find the third side. Very good. And how are we going to do that? 2 squared plus 1 squared equals h squared. Sure, that works for me. So 4 plus 1 is 5 equals the hypotenuse squared, and then we can take a square root and get the hypotenuse is radical 5. Super. And now we can find all the remaining trig functions. So we want to find sine of theta, cosine of theta. We know tangent of theta, so we don't have to find that one. Let's start with just the big 3 here. What would the sine according to our angle theta be? 2 over radical 5, which is a lovely answer, but needs to be rationalized. Very good. So we're going to multiply top and bottom by radical 5, and that gives me 2 radical 5 over 5. Good. What is cosine according to angle theta? 1 over radical 5, adjacent over hypotenuse. And again, to rationalize, you're going to get what? Radical 5 over 5. Yeah, I hope you can do that in your head really easily. Okay, so we have the big 3. I need the reciprocal functions. What's the reciprocal function for sine? Cosecant of theta. Cosecant of theta, I'm just going to do hypotenuse over opposite. So radical 5 over 2, which comes from that first one. When you guys are in calculus, I'm going to tell you don't rationalize. So, all right, what is the reciprocal function of cosine? Secant. Secant of theta is, again, just the reciprocal. So radical 5 over 1, or just radical 5. And what's the reciprocal of tangent? Cotangent, yeah. Which would be what? 1/2. Very good. Okay. Excellent day. God bless you.
Thanks.
All right. Any questions on those? All right. You can draw a picture. Okay. All right. Example 2. Use the given function to find the indicated trig functions of acute angle theta. Use the given function to find the indicated trig functions of acute angle theta. I don't know why I forgot to space those out, but they probably want a line. Probably want a line or two. Okay, here we go. So again, they're telling me in this information that I have acute angle theta. So again, that's angle theta in standard position, and he's very cute. So again, acute being less than 90 degrees. So I'm just going to draw any size. Doesn't really matter. But here it is. There is my little acute angle theta. And then I have this other information that says the secant according to theta is 5. Well, my so good Toa doesn't tell me anything about that. So what do I need to do?
Go to cosine and split it.
Oh, so if secant of theta equals 5, cosine would equal, 1/5. Okay, well, that's useful. All right, so this is also true. Secant is just the reciprocal of cosine, which means 5 over 1 really represents hypotenuse over adjacent instead of adjacent over hypotenuse. Okay. Well, in order to draw that information on here, or even this information, adjacent over hypotenuse, what do I need to do?
The altitude thing.
The altitude. Yeah, we're going to drop an altitude. So I'm going to pick a point on my terminal side and drop an altitude so that I get a lovely little right triangle. And now I have, where is my hypotenuse? The terminal side here is the hypotenuse, and the opposite, the vertical leg of that one, yeah. And the adjacent would be on the x-axis, yes. So that's the adjacent side there, good. And because we have both of these little pieces of information here, I know my hypotenuse is 5 and my adjacent side is 1. So what do we need to do? Find the third side. I'm going to call it y because O doesn't work very well. So I have 1 squared plus y squared equals 5 squared. So y squared equals 24. And if you take a square root, then you would get 24 is 4 times 6. How does it simplify? Yeah, 2 radical 6. So the square root of 4 is 2, and that radical 6 stays behind. I'm going to write it both ways, 24 and 2 radical 6, because sometimes radical 24 is better. Okay, tangent. So what is tangent according to our little triangle? Opposite over adjacent would be 2 radical 6 over 1, or just 2 radical 6. Opposite over adjacent. What would cosecant be? 5 over 2. So you're telling me, so it's not opposite over hypotenuse, it would be? Hypotenuse over opposite. Okay, so the hypotenuse is 5 over 2 radical 6. What's wrong with that answer? It's not rationalized. So what do you do there? With what? Times by radical 6. The 2 is fine, so we only need to multiply by radical 6, top and bottom. So in the numerator, we would get 5 radical 6. In the denominator, what is radical 6 times radical 6? 6 times 2, 12. All right, so 5 radical 6 over 12. Okay, letter D I'm going to do down here. So this is interesting notation. Cotangent squared theta is how we would read that. And this is actually the shorthand notation for cotangent of theta and square the whole thing. So that means the same thing. Those are identical statements. All right, what can I do with cotangent? What is cotangent according to theta? The reciprocal of tangent, so adjacent over opposite, what would that be? 1 over 2 radical 6, or I'm just going to put radical 24. And I'm going to square it. What is radical 24 times radical 24? 24. That's why I chose that one. So we get 1 over 24. If you square 2 radical 6, you should get the same thing. All right. Now, letter E is very interesting. This is kind of weird notation. They want to know cosecant of 90 minus theta. And I want to know what exactly that means. And so I'm going to go back to what I did on the first slide. If I have a triangle, and I know this angle is a right angle. If this angle is 10 degrees, what's this one? 80. Good. Okay. So then if this angle is 20 degrees, what's this one? 7. Okay, good. Good. How are you getting 70? 90. Oh, you're doing 90 minus this angle? Oh, so if this angle is theta, what would this angle be? 90 minus theta. Oh. So here's our angle theta. What could we call this angle right here? 90 minus theta. So really, this notation, 90 minus theta, is just how we mathematically would say the complement. The other angle, the complementary angle. All right? The cosecant of this angle is going to be the same as first period, got it, but never mind, so it's fine. So what this means is we're looking from up here. This is our 90 minus theta angle. How do we find the cosecant ratio? Opposite.
Sine, but backwards.
Okay, the reciprocal of sine. So hypotenuse over opposite. All right, so what's the hypotenuse? 5. Now, looking from the other angle, what's the opposite side? 1. There it is, Robert. Yes, so 5 over 1 or just 5. So cosecant of 90 minus theta is the same as secant of theta. That was the whole co-function thing. Okay. All right. But it works out. I mean, it's the same. You can just do it instead of memorizing another theorem. So I don't spend a ton of time on it. All right, but that's what I want you to understand, that 90 minus your angle would be the other angle that we have there. Okay? Questions on that one? Okay. So now all of the actual identity stuff. Here we go. Yeah, today's long. I told you it was. All right, so reciprocal and quotient identities. We've talked a little bit about the reciprocal identities, but I just sort of laid it out there for you. So we're going to talk about them again but really so that you know how to use them in your calculator. So I mentioned that if I have the sine of an angle theta, what's its reciprocal function? Cosecant. Good, good, good. Okay, so reciprocal actually is 1 over cosecant of theta, and that whole 1 over is what causes the fraction, that ratio, to flip. So it turns it into a complex fraction, and then you multiply by the reciprocal. That's how that ratio flips. We can cross multiply and swivel this stuff around. So it says cosecant of theta equals 1 over the sine of theta. And these two things are equivalent. So this is the meaning of reciprocal. It's 1 over something. The reason you need to know that is so that you can plug something like that into your calculator. If I asked you to find, like, let's see, the sine of let's not do the sine of 60 degrees. Let's do the sine of 30 degrees. You have a calculator, and so you should get that out. Because I want you to know how to do that. Now, most of the time, we're going to be in radian modes, but for this first one today, is this 30 in radians or degrees? Degrees. How do you know that? Degree symbol. Very good. Okay. Which means because we're in degrees, we want our calculator to be in degree mode. And so you have a mode button on your calculator. And so you're going to go to mode, and you see there's these choices right here where it says radians or degrees. And we want to be in degree mode because we've got 30 degrees. Okay, and then you can quit. And then if you want to find the sine of 30 degrees, you just type in sine of 30. And it equals 0.5. Okay. Oh, kind of cool. So then the question is, well, that's great and all. So how do we figure out the cosecant of 30 degrees? Because I don't have a cosecant button. All I have is sine, cosine, and tangents. So I hear a lot of people saying, is it this sine to the -1? Which that actually means sine inverse. That's the shorthand notation for inverse. So that's an entirely different function. And so we have to go to the reciprocal identities. And so cosecant is the same as 1 divided by the sine of the angle. And so if you wanted cosecant, you'd have to type in 1 divided by the sine of 30 degrees, which would be 2. Okay. So with that knowledge, then we also, what would secant of theta be the same as? 1 over cosine of theta. Yep. And what would cotangent of theta be? 1 over tangent of theta. Yes. Okay. So these are the reciprocal identities. And it's important that you, really the reason you want to know those is so you can type them into your calculator properly. That's the bottom line. Now, we also have quotient identities. The quotient identities, there's 2 of them, and we use these all the time. And the first one is tangent of theta. It turns out that tangent of theta is the same as sine of theta over cosine of theta. That's a big one. Well, that's kind of interesting, and I'm going to show you why. I'm going to give this triangle some numbers. I'm going to say it's a 3, 4, 5 triangle. Okay, those are some side lengths for a common right triangle. And so we can actually just use numbers to figure this out pretty easily.